Okay, so lesson 3 is about box and whisker plots. Separating data into subsets is a useful way to summarize and compare data sets. So quartiles are values that divide a data set into 4 equal parts. Okay, the median is also known as quartile 2 or the second quartile. Let's see. And that separates data into upper and lower halves. So basically your median is your middle, and then you have an upper half and you have a lower half of data. So the first quartile, or quartile 1, Q1, is the median of the lower half of the data. And quartile 3, which is also Q3, is the median of the upper half of the data. So we're using median a lot here. The interquartile range is the difference, so that means subtraction, between the third and first quartile. So that is a lot of definitions, a lot of stuff thrown at you, but it's going to make more sense once we start actually doing some problems. So for a set of data that has an odd number of values, you do not include the median in either half when finding the first and third quartiles. Again, I know that sounds really confusing right now, but it will make more sense. Okay, so we're going to go ahead and do a little example here. And it says, use the data set and place the values in the correct blanks to find the minimum, first quartile, median, third quartile, and maximum of the data set. So our first step is always to arrange the data from least to greatest. We've been doing this. It's going to make more sense, like I said, once we actually start doing some more examples. So from least to greatest, we have 80 as our smallest, so that's our minimum. Okay, then our next number here is 125. We have 2 126s that it already has for us. Then we have 2 135s that it also has for us. 140, 140, 140. So there's 3 140s, a 150, and our maximum is going to be 350. Okay. So we kind of already talked about it, but the minimum value is 80. That's your smallest value. And the maximum value is 350. That's your biggest value. Okay. So it tells us, actually up in example 1, which I didn't see, it tells us to find the median. So we know that the median is the middle number. So I'm going to go ahead and cross off on each side. So we end up with a median of 135. So it then tells us for number 3, the values to the left of the median. So that's your smaller half of your data. That is 80, 125, 126, 126, and 135. Okay, we do not include that median value since we have an odd number of data points. Okay, so the values to the right, so your upper half of your data are 140, 140, 140, 150, and 350. Okay, so it says the median of the numbers to the left of the median are what? So that's your lower half here. So we need to find the median of that data by crossing off again on each side, which gives us a median of 126. This is considered, since it's the median of our lower half, that's going to be our quartile 1. So that's the first quartile. Okay, then it says the median of the numbers to the right of the median. So now we're looking at our upper half of data. So we're going to go ahead and cross values off, and we get a median of 140. And that is considered the third quartile, or quartile 3. So this is Q1, this is Q3. If you're like, well, where did Q2 go? Q2 is the median of all of the data. So that original 135 that we found, that's your quartile 2. Okay, so then it says rewrite all of the ordered data values below and then answer the questions that follow. Okay, so let's go ahead and rewrite. We have 80, 125, 126, 126, 135, 135, 3 140s, a 150, and a 350. Okay, so this kind of outlines everything for us. We have our minimum value of 80. It has an arrow going up to Q1, which is 126. That's what we found. Median of, or Q2, which is 135. Q3 at 140. And we have a maximum at 350. Okay, so now that we've rewritten everything, it says, what is the interquartile range? So earlier we talked about interquartile range being Q3 minus Q1. So we're taking our Q3 value and subtracting Q1. So we're taking 140 and subtracting 126, which leaves us with an interquartile range of 14. For part B, it says if the data represents scores on a test, what was the highest score? Well, now we're looking at our maximum. That's the best score that somebody got. So we have a high score of 350. And we have a low score at our minimum of 80. Okay, at the very beginning, we talked about this being split into 4 equal parts. So what this does is splits the data into 4 equal parts. So we have, let me go back and write this. We have a part here, we have a part here, we have a part here, and we have a part here. So if it's splitting 100% of the data into 4 equal parts, we can say each part is representing 25% of the data. For a total of 100% of the data. So it says about what percent of scores were on or below 135. So we're looking right here. And it says here or below. So we're looking there and then to the left. So if you look, we have 25% here and 25% here. So 50% of our data is at 135 or below. And it says, how can you tell without calculating? Well, we know that it's split into 4 equal parts. So each part has to be a fourth. And so a fourth and a fourth gives us 2/4, which is equal to a half. So 50%. Okay. About what percent scored below 126 and 140 inclusively? I'm sorry, between 126 and 140. So we're looking at between 126 and 140. So we're looking at, again, about 50% of our data. About what percent of scores were above 140? So we're looking at these numbers here. And that's going to be approximately 25%. Okay, so here for number 8, it already gives you the data and it gives you everything in order from least to greatest. So we need to come up with, it says what's the minimum, I'm going to say min, quartile 1 or first quartile, Q1, the median, I'm abbreviating here, quartile 3, and then it says what's the maximum as well. Okay, so we have 5 things to find. Now, minimum and maximum are probably our easiest to find because we can look at this. The data is already in order, so it's already in order from least, which is 60, so that's our minimum, to greatest, which is 105, so that's our maximum. Now, the next thing that I like to find, or that you need to find next, is the median. So we're going to cross off on both sides. And we end up with a problem here. We have two numbers in the middle. And if you remember from the last lesson about central tendency, what you have to do with those two numbers is add them together and divide by 2. So 84 plus 85 and then divide by 2, which gives me 84.5. Okay. Now, we haven't done an example like this yet, but whenever you have two numbers in the middle, the lower values, you're then looking at everything to this point. Okay, that's going to help you find Q1. And then for Q3, you're looking at the 85 and everything above that. Okay, so in order to find Q1, I'm going to go ahead and I'm going to rewrite. I have 60, 65, 75, 75, and 84. And if I start crossing off from each side, I end up with a middle value of 75. So that's going to be my Q1. You have to do that on the other side too, which gives you your Q3. So again, I'm going to go ahead and rewrite. And I'm going to cross off on both sides, which leaves me with 95 for my Q3. For number 9, it's actually asking you to do the exact same thing. So here, it doesn't give you the numbers in order from least to greatest. So we're going to go ahead and have to do that. So we start with 5. And then go from least to greatest. Okay. So my data set is in order. Once I have my data set in order, I can go ahead and start filling out all my things that I need here. Let me go ahead and write that out. Okay, so minimum, we should be able to see that right off the bat. We have a minimum of 5, and we have a maximum of 53. Okay, the next step again is finding the median, so finding the middle. I'm going to cross off on both sides. And the problem here is I get 19 and 11. So if I add those together, I get 30, and I can divide by 2, which gives me 15. Now, again, since we had an even number of data set, or even number of data points, we're going to include that 11 on the left side. So we have 5, 7, and 11 for our lower half of our data. So if I go ahead and I cross off on both sides, I end up with a quartile 1 of 7. Then for Q3, I have 19 to 53. So I have 19, 21, and 53. And if I cross off on both sides there, I end up with a middle value of 21, which is my quartile 3. So I've gone ahead and I found everything I need for number 9. At this point, you're probably asking why we have to do all this. So what this stuff is getting us ready for is creating a Box-and-Whisker plot. And that is a graph that summarizes a set of data by displaying it along a number line. Okay, it consists of 3 parts, a box and 2 whiskers. So we have our whiskers here on each side, and then we have our box in the middle with our median in the for Q2. So if you look at this, it says the left whisker extends from the minimum to the first quartile. So that represents 25% of our data, approximately. So although it doesn't necessarily look like it, that's 25% of our data. The box extends from the first quartile to the third quartile and has a vertical line through the median. The length of the box represents the interquartile range, and it contains about 50% of the data, which means that each part here, this right here is 25%, and this is 25%. Okay, the right whisker extends from the third quartile to the maximum, and it represents 25% of the data. So this is kind of like what we were talking about earlier. Each portion is 25% of the data to add up to a total of 100%. Now, if you look at this though, it doesn't look like they're equal. Okay, and that's okay. That just means that from the minimum to quartile 1, there's a greater range there. Okay, if you look at the boxes from Q1 to Q2 and from Q2 to Q3, there's a difference in the width of each of those boxes. So all that means is that there's a difference in the range of the data that still is representing 25% of the data though. All right, so if we look here, it says create a box and whisker plot of the data in example 8. So I'm going to scroll back up here. Let's see, we have a minimum of 60. We had a Q1, I think it was, or I'm sorry, yeah, Q1 of 75, I think. Yes, a median of 84.5. A Q3 of, I want to say it was 95, but let me check. Yep, and a maximum of 105. So at this point, it's saying create a box and whisker plot. So the first thing you have to do with a box and whisker plot is create a number line. Okay, and we need to start at least 60 because that's our minimum value. And we need to go all the way to 105. So I'm going to go by 5s. You can go by a different interval. I just think 5s will work out nicely. I'm going to go ahead and get rid of this. Oops, I just erased the whole thing. Okay, so at this point, what we want to do is I'm just going to put a point at every single the minimum, the quartile 1, the medium, Q3, and maximum. So I'm going to put a point at the minimum above the line, not on the line, above it. And then I'm going to go to my Q1. My median is at 84.5, so I'm almost to 85, but not quite there. Q3 is going to be 95, and then I have a maximum of 105. So I have all my data points. And if you look back up at this picture of the box and whisker, we have a whisker to start out. Okay, so that's our first part, is our whisker. And then we have a box around from Q1 all the way to Q3. Okay, with a vertical line at my median. From there, we end up with a whisker to our maximum. So we've just created a box and whisker plot for example 8. Now it says about what percent is below 75. So we're going to go ahead and we are going to look at our 75, which is right here. Okay, and it's wanting everything below that. So everything to the 60. Now, we talked about earlier, every single part of our box and whisker is 25%. So since this is only one part, we have 25% of our data right here. I'm going to go ahead and label each of these as well as 25%. So we know that for the next couple questions. Okay, it says about what percent is above 95. So now we're looking here and we're going everything above that. So everything greater than that. So all the way to 105, and it's saying what percent? Well, approximately 25% of the data is above 95. We also talked about this already too. It says, why are the whiskers different lengths? So I told you that they're different lengths because of the ranges. Okay, so from 60 to 75, that's a bigger range, but it still is only consisting, or it only has 25% of the data in that range. Okay, so we've kind of already talked about C. So let's go ahead and let's move on to number 11. It says the charts list the average high temperature for each month in Alton, Illinois. Create a box and whisker plot for the data. Okay, so the first thing I want to do, like I always want to do, is go ahead and put everything in order from smallest to greatest. So my lowest temperature here is 37. Okay, then my next lowest is 42, and I have 2 of those actually. Okay, then we go to 53, 54, 66, 68, 75, 80, 84, 86, and 88. Okay, so we have all of our data represented here, and it's in order from least to greatest. So the 5 things that you need to create your box and whisker plot are your minimum, your Q1, your median, your Q3, and your maximum. Okay, so it's kind of easy again to see the minimum and the maximum data. Okay, now we have to find the median. So we have to find the middle. So we're going to go ahead and cross off on each side. And we end up with 2 numbers in the middle again. So what that means is we have to add them and divide by 2. So 66 plus 68, and then divide by 2, and that gives us 67 as our median value. Now, since we had those 2 numbers in the middle, you have to include 66 in your first half of data. So again, you can either rewrite, or I'm just going to actually cross them off again from here. So with the pink, I have 37 and 66, 42 and 54, and then I end up with 42 and 53 in the middle here. So in order to find the median, I have to add them together, and I have to divide by 2. So 42 plus 53, and then I need to divide that by 2. And I get 47.5. Okay, then I'm going to do the same thing with the second half of my data, include the 68, and I'm going to cross off again on both sides. So I end up with 80 and 84. If I take the average of that, I add them together and divide by 2 again, I get 82. And now it's wanting us to go ahead and create that box and whisker plot. So I'm going to first draw my number line. And with my number line, I have to at least start as low as 37. I'm going to start at 35. And I think this time I'm actually going to go up by 10s. So 45, 55, 65, 75, 85, and then 95. Okay, you can go by smaller intervals, and that's perfectly fine. I mean, we could even put 40 in between here, 50, and just go by 5s instead, if you wanted to do that. That way it's a little easier to see everything. So from here, what you have to do, again, put a point at your minimum, which is 37. So I'm going to be approximately right here. It's not going to be 100% perfect. 47.5. So you're going to be here. 67, you're going to be a little bit past 65. 82, you're going to be a little bit past 80. And then a maximum 88, so you're almost to 90, but not quite there. Okay, so your first part is, again, a whisker. And then you have a box around Q1 to Q3 with a line, a vertical line at the median. And then you have a whisker. Okay, so we've created a box and whisker plot for number 11. It says, about what percent of the average height temperatures are between 47.5 and 82? So here you're looking at 87.5 to 82. So if each part is 25%, that means that we have 25% here and 25% here, which gives us a total of 50% of our data between those 2 points. Okay, moving on. Looks like this is our last little portion here. So with this one, it says use the box and whisker plot below to answer the following questions 12 through 18. So we're going to kind of use what we know about box and whisker plots, and we're going to go ahead and put that to use here. Okay, so what do the interquartile ranges tell you about the average monthly rainfall for each city? Okay, so if you look here at Miami, Miami has a very large interquartile range. So from Q1 to Q3. Then if you look at New Orleans, you have a pretty small range from Q1 to Q3. So what that's basically telling us, I'm probably not going to write much here, I'm just going to kind of talk you through this, is that the ranges of average monthly rainfall for Miami is a lot larger than it is for New Orleans. Okay, so New Orleans has basically a set amount of rain that it gets, but Miami has a very sporadic amount of rain. Okay, what do the medians tell you about the average monthly rainfall for Miami and New Orleans? So median is that middle vertical line. Okay, so what that's telling us is that New Orleans, on average, gets more rain than Miami does. Okay, or has a higher median, I guess we should say, than Miami does. Okay, let's go ahead and erase this. Okay, about 75% of months in New Orleans have blank or fewer inches of rainfall. So we're looking at New Orleans, so we're looking at the bottom box and whisker. So it's saying has blank or fewer inches. So we're looking at your Q3 and below that because it's 75% of the data. So that's saying this is 25, this is 25, and this is 25%. Okay, so that would be 75% if you added all those up, in anything less than that. So we're saying approximately, if we were to kind of draw that all the way up, we have New Orleans have 6 or fewer inches of rainfall on average if it was 75%. Which city has a larger variety, which means range, of values of monthly rainfall? So if you look at this, range we can tell by taking our max minus our minimum. So we're going from here to here, and then from here to here. So which of those is larger? So we would say Miami here. It has a greater span from here to here than New Orleans does. All right, let me erase. Sorry, it's kind of lagging here. There we go. All right. says circle the statement below that must be true and explain your reasoning. Statement 1 says at least 1 month in New Orleans averaged 3 inches of rain. So if we're looking at the New Orleans, again, we're looking at our bottom Box-and-Whisker. So it says average 3 inches of rain. So if you look at the 3 inches here, there's definitely 1 month where there's 3 inches of rain. So that statement must be true. So if statement 1 is true, sorry, I don't know what's going on here. If statement 1 is true, then that means statement 2 it doesn't necessarily have to be true. So at least 1 month in New Orleans averaged 6 inches of rain. So we're looking at Q3 because that's where our 6 is. But if there's an even number of data points and you had to find the average in order to find Q3, that wouldn't necessarily have to be true. Okay, so statement 2 is not necessarily true. Is it more common for the average monthly rainfall in Miami, Florida to be above 4.5 inches or the average monthly rainfall in New Orleans to be above 4.5 inches? So we need to look at the 4.5. So we're looking right here. Goodness gracious. For some reason, everything's kind of lagging here. All right, so we're looking at 4.5 on both of these. So 4.5 is going to be right through here. Of course, let's see. There we go. All right, so if we look, Miami has, on average, 50% of its data is 4.5. Okay, now if you look here, we have 25, 25, 25. So we have 75% of our data plus this little amount here. So that's definitely going to be more of the data is above 4.5 in New Orleans. So we're going to say New Orleans. Okay. And then true or false, the average monthly rainfall in Miami, Florida can be seen in the plot above. Well, average is the mean. We can't necessarily see the mean of the data. The only thing that we can see here is the median. So this would actually be false.